Number System Lesson 15. We have seen that if number n is expressed as a raised to power p into b raised to power q into c raised to power n, then the number of factors is p plus 1 into q plus 1 into r plus 1. And n can be represented as a product of two factors. If number of factors is even, then phi n by 2, or if number of factors is odd, then phi n plus minus 1 by 2. Now we will see that if the question is express n as the product of two co-prime factors. What is co-prime factor? Co-prime factors are whose HCF is 1. For example, 4 and 5. These are co-prime factors. For example, 6 and 11. These are co-prime factors. So product of two co-prime factors. If the question is expressed n as product of two co-prime factors, then the formula for that is 2 raised to the power m minus 1, where m is, if the question number n is expressed as a raised to power p into b raised to power q into c raised to power n, then m is this number of these prime numbers a, b, c. Here m is 3 because a, b and c, these are 3. So m is here 3. Product of two when the question is expressed n as product of two co-prime factors, then the formula is 2 raised to the power m minus 1. Let's take example 48. 48 can be written as 2 raised to the power 4 and 3 raised to the power 1. So number of factors is 4 plus 1 into 1 plus 1, that is 10. You can even check 48 can be written as 1 into 48, 2 into 24, 3 into 16, 4 into 12 and 6 into 8. So these are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now express n as product of two factors. What will be the formula was phi n by 2. Why? Because this is 10 is even. So phi n by 2, that is 5. You can even check, this is 5. 1, 2, 3, 4 and 5. Product of two co-prime factors. 2 raised to the power m minus 1. Here m is 1 and 2. 2 and 3. So there are two prime numbers. So m is 2. 2 raised to power 2 minus 1, that is product of two co-prime factors is 2. Let's check. Co-prime factors here is 1 into 48 and 3 into 16. These are not co-prime factors. Why? Because here HCF is 2. Here HCF is 4. Here HCF is 2. But here HCF is 1 and here HCF is 1. So this and this are co-prime factors. But there is no need to do this. Just find out by using the formula 2 raised to power m minus 1, that is 2. Okay, let's see another example. 36. It can be written as 2 raised to power 2 and 3 raised to power 2. Number of factors is 2 plus 1 into 2 plus 1, that is 9. Let's just check. 36 can be written as 1 into 36, 2 into 18, 3 into 12, 4 into 9 and 6 into 6. So number of factors are 1, 2, 3, 4, 5, 6, 7, 8, 9. Because 6 are double, so we are just calculating it as 1. Okay. Now phi n is odd here. So n should be perfect square. 36 is a perfect square. Yes, it is a perfect square. It is 6 into 6. Perfect square. Express n as the product of two factors. Express 36 as a product of two factors. Phi n plus minus 1. So we will take phi n plus 1 by 2. Okay, that is 5. Why we have taken plus 1? This will give the product of two factors. But if the question is product of two distinct factors we have to calculate, then we will do n minus 1 by 2, that is 4. 8 by 2, 4. Let's just check product of two factors. Obviously it's 5, 1, 2, 3, 4, 5. Okay, but product of two distinct factors is 4. Here this has been omitted because these are not two distinct, only this and this are distinct factors. Now the second is the product of two co-prime factors. It's what? 2 raised to power m minus 1. Let's check what is m here. 2, 1 and 2 raised. 2 and 3 are 2. M is equal to 2. Two prime numbers are there. So 2 raised to power 1, that is 2. Product of two co-prime factors is 2. Let's just check. Here co-prime number factors are 1 into 36, 2 into 18, no. 3 into 12, no. 4 into 9, yes. So we have two co-prime factors. So express 30 as a product of two co-prime factors in two ways. This is your answer. Bank PO question. What is the unit digit in 6374 raised to the power 1793 into 625 raised to the power 317 into 341 raised to the power 491? This seems to be a very difficult question, but it is not that difficult. Let's just find out the cyclicity for 4, 5 and 1. Cycle for 4 is, just check, 4 raised to the power 1, 4, 4 raised to the power 4, 2 is 16, that is 6, 4 raised to the power 3 is 6 into 4, 24, that is 4. Now this is repeating. So its cycle is 4 raised to the power 2 with the result of 6. For 5, 5 raised to the power 1, 5, 5 raised to the power 2, 25, again 5. So cyclicity is 5 raised to the power 1 with the result of 5. And obviously 1 raised to the power anything is 1 only. Okay, so let's just take this first. 6374 in raised to the power 1793. Just take 4 raised to the power 1793. Okay, because we are just focusing on the unit digit. So just 4 raised to the power 1793. Now the cyclicity is 4 raised to the power 2. So express 1793 in terms of 2. So 4 raised to the power 1792 into 4, because 1793 is not divisible by 2. So to make it divisible, you just split it. 4 raised to the power 1792 into 4. Now is it divisible by 2? Yes. So just divide it by 2. You will get 4 raised to the power 2 into 896 into 4. Okay. Now 4 raised to the power 2 is what? 6. So just write 6 raised to the power 896. Now what is the cycle for 6? Cycle for 6 is 6 raised to the power 1 is 6. 6 raised to the power 2 is again 6. So cycle for 6 is 6 raised to the power 1 with the result of 6. That is 6 anything is unit digit is 6. So 6 raised to the power and 896 is 6 with and into 4. So 6 into 4 is 24. So unit digit is 4. We have calculated unit digit for this, that is 4. Now calculate for 625 raised to the power 317. Take it 5 raised to the power 317. Okay, we have already seen that cycle for 5 is 5 raised to the power 1 is 5. That is 5 raised to the power anything. It always come as a unit digit as 5. So 625 raised to the power 317 is 5. This is 4. This is 5. Now 341 raised to the power 491. 1 raised to the power anything is 1. So here unit digit is 1. So we have got 4 into 5 into 1 at last. Now what is 4 into 5? 20. Unit digit is 0. 0 into 1 is 0. So 0 is your answer. That is the unit digit comes out to be 0. For more video lectures, subscribe us on YouTube and Facebook. For more study material, visit us allforlearners tutorials @blogspot.in. Don't forget to like and comment on our videos.